Welcome back to the Deep Dive. Today we are strapping in for a deep dive into the absolute cutting edge of human optimization.
We really are.
We're moving far beyond the standard wellness advice and talking about, radical longevity techniques, the fundamental role of muscle.
And these high-tech neuroenhancement strategies, it's a vast landscape. I mean, this is some of the most complex material we've ever tried to tackle.
It is. We've synthesized a whole stack of sources covering everything from genetic breakthroughs to these competing diet protocols from experts like David Sinclair and Peter Attia.
And we're going to try and connect the dots.
Exactly. The mission today is to unify the physical foundation of your skeletal muscle with that futurist frontier of gene therapy and AI. The goal is to give you a really comprehensive roadmap for maximizing your health span.
Right. We're not just talking about living longer, it's about the quality and capability of those years.
Okay, let's unpack this, starting with, the literal blueprint of aging itself.
So when we talk about anti-aging research, we have to understand what's actually, going on under the hood. What are the mechanisms of decline?
Right.
And our sources really focus on two foundational hallmarks of aging. The first one is damage accumulation, which you often hear about through the free radical theory.
Which, put simply, just sounds like the body's sort of rusting from the inside.
That's a perfect way to put it. It's wear and tear from what are called reactive oxygen species, or ROS. These are molecules generated just by living and breathing, and they can damage everything. Your DNA, proteins, cell membranes. The body is in this constant fight against cellular rust.
So that's the chemical damage. What's the other sort of biological clock ticking down?
That would be telomere attrition. If you think of the little plastic caps on your shoelaces. Telomeres are like that, but for your chromosomes. And every single time a cell divides, those caps get a tiny bit shorter. It's like a molecular clock.
And once they get too short, the cell just stops.
It either dies or it enters this dysfunctional state called senescence. And this isn't just theory. The sources are clear that this shortening is directly tied to a loss of regenerative capacity.
And it's even connected to some really severe premature aging disorders. It's a real physical limit.
It is. And that, of course, leads to the big question, how do we fight it? And scientists are really coming at this from two directions.
Okay.
There's geroscience, which is all about preventing the diseases of aging heart disease, cancer. The goal is to prolong your health span.
Makes sense.
But then there's biogerontology, which has a much more radical aim. It treats aging itself as the disease.
So the goal isn't just to delay death, but to make it independent of age entirely.
That's the idea. And the sources suggest we already have drugs that are doing more than just preventing disease. They're actually showing age-slowing effects.
And what's the biggest surprise on that front?
I would say rapamycin, without a doubt. It was originally an immunosuppressant drug,
Right.
but still